Good morning to everyone. I am Kamaleshwaran, a B Mechanical Engineering student at Sri Ramakrishna Institute of Technology. I am here to present my case study. Let me give a small introduction of unconventional machining process. A common conventional machining process are milling, drilling, and which are conducted on lathes and everything. This case study analyzes MRF for finishing optical lens surface for justifying the selection over completion mechanical and nano-finishing routes. Like common unconventional machining process, this MRF process also contains liquids and electromagnetic particles. When the electromagnetic is passed through the liquid and the abrasive materials get stiffness, and which helps in to removal of the materials. Here it shows the working principles of the MRF process, where it contains a rotating wheel and a magnetic field and the optical lens, which is known as the workpiece for this process. Equipments and machine setup which is required for this MRF process are the spindle and a lens holder and a polishing wheel and electromagnetic field and a fluid delivery pump and a fluid condenser in and a metrological process, where in this process all the abrasive materials mixed with the fluid. When the electromagnetic field is passed to this, the abrasive materials get stiffness, and which helps in the removal of the material in the polishing wheel. Using the polishing wheel, the material is removed in the lenses. Everything relates to the material removal rate. When everything increases, the material removal rate will be decreases. They are directly proportional. Some of the process parameters of the MRF are the wheel speed, magnetic flux, ribbon gap. Some of the application of MRF are the precision optics, astronomy, and semiconductors, defense and aerospace, medical devices, and consumer electronics, where these are the minute particles where the machining process and the finish should be very accurate and high precision. So hence the MRF are the best unconventional machining process to go on to these processes. Finishing of optical lens surface. For that we can use BK7 and fused silica and infrared optics and astronomical mirrors. These are some of the processes which helped in the MRF. Compare the MRF process with the other known processes, where the first known process is the conventional machining. As I discussed earlier, the conventional process are the lathes and milling and drilling. These are the processes which comes under the conventional processes. Then we also know some of the process, abrasive flow and magnetic abrasive and etc. Comparing to the MRF, other have less finishing, where MRF have high precision and high accuracy. Similar to other processes, the MRF process has certain advantages and disadvantages. Let us discuss about this advantages first. As I discussed earlier, the finishing will be better compared to the other processes. And the limitation of this MRF process is high capital and maintenance, and we need a high skilled operator to maintain this, and the particles should be maintained at proper conditions. Now let us conclude this. MRF is a unconventional machining process where it has high precision and a high accuracy, but the maintenance are very high, but the finishing will be good. So we use these applications in the optical lens and aerospace and other conditions. With this, I conclude my case study. Thank you.